Since I just introduced the symbols for all the measurements for you, I thought we'd take the opportunity to see how they're used in the real world. For instance, here we have a problem where you roll a ball across a table at a constant speed or a constant velocity. You've made some measurements on it. Your goal is to find out how fast the ball is rolling. Before you can do any calculations, you first have to understand the different measurements that are in there. For instance, here we say at a certain time, 15 seconds, the ball is at the 20 centimeter mark. After 19 seconds, the ball is at the 75 centimeter mark. Each one of these numbers is a specific measurement that we need to identify. So let's first start writing them down. We have, there we go, we have the 20 centimeter mark. Now if you read this, you'll say you begin your recordings, your time at the 20 centimeter mark. That's a position that tells us where the object is. Furthermore, that's the first position we talk about. Position is indicated by an X. It's the first one, so we're going to say this is the initial position. A short time later, the ball is at the 75 meter mark, or centimeter mark. 75 centimeter. This is once again a position. It's telling us where it is, and it's done at a later time. We're going to say that this is the final position. The times we can look at the same way. The first time measurement we made was at 15 seconds. That was the time it was made. So the time, the initial time we looked at was at 15 seconds, or 15 seconds after we started the stopwatch. The final time measurement we made happened at 19 seconds. Now, these are the measurements we're going to use to solve for the velocity. The actual equation for velocity you've seen before. Here are the new symbols. The velocity of an object is the displacement, or better yet, since we're not using d for position, we're using x for position. It's a change in position over a time period. Here is the definition. I'm even going to put 3 lines there saying it's the definition of velocity. Every velocity problem you do, where you know the displacement and the time period, this is the equation you should use. We don't know the displacement at the time period though. We only know positions and instant times. Defined, the delta x, it's a change in position. The change in anything is the final minus the initial. So to find the change in position, it's the final position, 75 centimeters, minus the initial position, 20 centimeters, for a total displacement or final change of position of 55 centimeters. This here is our delta x, or our change in position. Put a box around that so we can identify it. Next, we also have to know the change in time. Well, the change in time, the change in anything, is the final time minus the initial time. The final time being 19 seconds. The initial time being 15 seconds. It took a duration of 4 seconds for this ball to roll that distance. Delta t was the time. Now we can take these values, our equation for velocity, we defined it as delta x over delta t. Delta x was 55 centimeters. Delta t was 4 seconds. So to solve this, we take 55 divided by 4. Calculator. Hello, sir. 55 divided by 4. 13.75. Now our answer is not 13.75. Our answer has to have a unit on it. And the unit you will always use are these right here. Centimeters per second. If we had measured our position in meters, then the meters would have followed through. You would have saw meters here, and our units would be in meters per second. And it's very common for us to change units, especially these, so that's always measured in centimeters per second. Let's do a quick review and see how we can change this to meters per second. 13.75 centimeters per second. We want to change this to meters per second. 100 centimeters is in 1 meter. The centimeters cancel. We have meters per second. That's going to be our unit, meters per second. 13.75 divided by 100. You can do it in your calculator, but it is 0.1375 meters per second. This is how all of the velocity problems are solved. This was the first basic example.